So finally, some remarks on the particular case of the traffic conflict resolution problem we have been talking before. Remember, a number of flights cross a sector and they may have conflicts. And we are looking for a good combination of flight plan changes in order to reduce the conflicts. We have seen a very simple approach based on a speed change. Each flight will change or may change its speed when entering the sector, and we may consider only 4 possibilities: no change, to increase the speed in 5 knots, to increase in 8 knots, or to reduce speed in 5 knots. So 2 bits would be enough to specify which of these possibilities should be applied to one flight. So with this decision we can build the chromosome. This will be the chromosome model, set of bits organized into 5 sections, because we have 5 flights. And in this case, section 2 specifies the change in speed for flight number 2, and since we have this combination 1-1, that means that flight 2 must reduce speed 5 knots when entering the sector. So we have the chromosome model, and then with the chromosome model we can build the initial generation of possible solutions and start the process. But we also need to define the fitness function, and we may wish to consider not only the number of conflicts, that maybe is the most important figure, but you can also consider, for instance, the magnitude of the because we may prefer solutions where the changes are small, not so large. Or maybe you may prefer solutions where the number of changes is not very large. In this case, for instance, we have 4 flights that must change the speed. 4. Maybe there are other solutions where the number of flights that are affected, that must reduce that must change the speed, is less than 4, and this would be a better solution provided that the number of conflicts is the same or even less. This is an approach, but you have an alternative approach, that is the heading change, not the speed change. So when entering the sector, a flight can change the heading in order to avoid conflicts. Again, we can consider only a reduced number of possibilities in the heading change. In this case, only 4 possibilities. So the chromosome again will be a set of bits organized into 5 sections, because we have 5 flight plans, and in this case the change to be applied to flight 2 is to increase the degree of the heading 5 degrees in this example. Very similar to a speed change, but in this case we are talking about heading change. And in this case we can consider other factors when building the fitness function. For instance, together with the others, we can add this new criteria. Maybe we may wish solutions where the new exit point in the sector, the new exit point is not very far away from the original exit point. It would be maybe a good thing to consider, not only number of conflicts, number of changes, or magnitude of changes. And even more, we can combine heading and speed change. So when a flight enters the sector, we can apply a change in speed and also a possible change in heading. In this case, the chromosome model, again 5 sections, and in each section we need 4 bits, two of them to specify the change in speed, and the other 2 to specify the change of the heading. And even more, we can consider a model where there are 2 moments for flight plan change, maybe in the when entering the sector and in the middle of the sector. In both moments, a flight can change the speed and also the heading, not only when entering but also when the flight is in the middle of the sector. So in this case, each section of the chromosome model, each section needs 8 bits, 4 of them to specify changes when entering, changes in speed and changes in heading, and the other and 4 more bits to specify changes in the middle of the sector. So this is another approach. As you can see, there is a lot of possibilities and approaches, and you must make a decision on your preferred approach, or you may compare different approaches. And again, remember that you have many possibilities for the selection criteria, for the crossover criteria, for the mutation criteria, and also for the termination of the search. So you will have to make you will have to define your model, and to that purpose you have to make a decision on all these elements: the approach, the chromosome model, and all these, the fitness function, and all these criteria.